Okay, so this is the problem that I'm going to be explaining. So we have k equals 2008 squared and then plus 2 to the 2008. And then we want to find the units digit of k squared plus 2k, 2 to the k. So if we just put everything as mod 10, then that simplifies a lot. And it also works because all we care about is the units digit of what this is. So if we find the units digit of this and then the units digit of this, and then we take the sum of that, that's the units digit of k. And then if we take the units digit of k and then we plug it into here, and then the units digit of that is what we want to find. So we'll just find that. So 2008, the units digit, only the units digit matters for finding the units digit. So we'll just take 2008 mod 10, which is 8. And so we have if we're taking it to the squared, so 8 squared is 64, which means it's 4 plus, then 2 to the 2008. The pattern for 2s is 2 to the first is 2. 16, which is congruent to 6. And then from 6, that's, and so if you can't tell, it's a pattern of 4. It repeats every 4, which is also called a period of 4. And so 2008, if we check, if it's, for dividing it by 4, 2008 is exactly divisible by 4, which means it's 0, in other words, also 6. And so, it's 6, which is, in other words, 0, and so, we have k is congruent to, k is congruent to 0 mod 10, and k squared, if k is 0 mod 10, then this would be equal to 0, congruent to 0 mod 10 as well. And so, okay, so 2008 to the 2, and then 2 to the 2008 is a multiple of 4, which means it's multiple, k is a multiple of 4. And so the unit digit of that would be the powers of 2 cycle in 4s. So 2 to the k, so 2 to the k, k is a multiple of 4, which means it has to be a 6. And so we have k squared and then 2 to the k, which means 0 plus 6 is congruent to 6 mod 10, which is the unit digit. And so the unit digit